Good morning, everyone. Myself, Ashu Sharma. I welcome you all in series of My SQL and Python. Today, we will learn performing transactions. So let's start with next slide. Okay. As we all know that in database, there is a asset properties concept. So we have this atomicity, consistency, isolation, and durability. To make database consistent, it is important that these properties should be whole. We will try to understand each one of them one by one. So let's start with atomicity. This property ensures that either all the operations of a transaction reflect in database or none. Mean to say, if a transaction begins, then definitely it should commit, it should complete. If it doesn't happen, then it should not start. So either yes or no. So let's take an example of banking system to understand this. Suppose account A has balance of $400 and B has $700. Account A is transferring $100 to account B. This is a transaction that has two operations. One operation is debiting $100 from A balance, and another operation creating $100 or crediting $100 to B's balance. Now suppose if first operation passed successfully while second failed. In this case, A balance would be $300 because debiting is already done, but crediting is not done, while B would be $700. So instead of $800. This is unacceptable in banking system. Either the transaction should fail without executing any of the operation, or it should process both the operation. The atomicity property ensures that. So if this type of transaction happen, it is a single transaction. Transaction is you can say small part of unit in which low level tasks are going to be executed. So if we combine these two operations into a single transaction, then debiting is happening, but crediting is not happening. It is not accepted. It is a violation of atomicity. Both operations should be successful. Then only atomicity holds. This is the concept which brings that what transaction is going to be start that should complete successfully. And in a transaction, because it's a small part, there are several low-level tasks or operations. Those operations should complete successfully. Then we say atomicity ensures and database remains consistent. Next, we move to the consistency. To preserve the consistency of a database, the execution of transaction should take place in isolation. That means no other transaction should run concurrently when there is a transaction already running. So if suppose two transactions are running, so one has to complete, then second one will start or begin. For example, account A is having a balance of $400 and it is transferring $100 to account B and C both. So we have two transactions here. Let's say these transactions run concurrently and both the transaction read $400 balance, which is A having, account A having. In that case, the final balance of A would be 300 instead of $200. This is wrong because if you are looking for this example that initially A account having $400 and it is transferring $100 to each B and C both, it means first it should transfer that amount to account B, then it becomes 300, and then it transferred to account C, then it becomes 200. So it is not happening because both transactions, if you see, here is an error. It is running that $400 initially for account A. This is wrong. If the transaction were to run in isolation to make that consistency, to preserve the consistency of the database, then the second transaction would have read the correct balance $300 before debiting $100. Once the first transaction went successful. So once that first transaction went successful, then for crediting money to account C, it reads that $300 left, and $300, if $100 is debiting from there, it remains with 200. So this is the part of the isolation, which is the next point. So if preserve the consistency of a database, it's very important that every transaction should take place in isolation mode. Then only we can say that preservance of consistency of a database occurs. Now move to the next point, isolation. For every pair of transactions, one transaction should start execution only when the other finished execution. I have already discussed this example previously, that isolation is that very important to make consistency of the database. So this is an important point. Every pair of transaction, one transaction should start execution only when the other finished execution. This is important. Next is durability. Once a transaction completes successfully, the changes it has made into the database should be permanent, even if there is a system failure. The recovery management component of database system ensures the durability of the transaction. So once a transaction completes successfully, the changes it has made to the database, it should permanent, even though there is a technical failure or system failure. And the recovery management component of database system ensures durability of the transaction. So one thing is clear, that in the master database, changes would not appear until that transaction is not going to be committed. So changes in the master database is only appearing when the transaction completes successfully. So when these four property holds, then we say it helps us to manage the transactions management as well as the consistency of the data. This is important. Now we will see further some of the methods and brief example. We have commit method, rollback method, close method, execute. There are few methods that we require in order to follow the steps to manage the transaction. Let's see further. Next is this, methods to manage MySQL database transactions in Python. Python MySQL connector provides the following method to manage database transaction. The first one is commit, MySQL connection.commit. So as we all do have this practice of creating connection object and cursor object, we do have that practice. So connection.commit method sends a commit statement to the MySQL server and committing the current transaction. If transaction successful, completes. Second one is rollback. MySQL connection.rollback revert the changes made by the current transaction if a sort of failure, a sort of error happens. If any of given transaction fails, or any of that query which is not successfully execute, then rollback revert the changes made to the current transaction. This is the property of rollback method. Auto commit is always having the by default value is false, and it can be assigned as true or false both to enable or disable the auto commit feature of MySQL. But by default, its value is false. Now move to the next slide. This is the syntax. Syntax of commit method. Once the program completed executing the query with your changes and you want to commit the change to the database, to the master database, then you need to call commit method on MySQL connection object as follows. You create connection object and you call in commit method connection.commit to make changes to the database. Next is syntax of rollback method. When one of the transactions failed to execute and you want to revert or undo all your changes, then you need to call a rollback method of MySQL. And it's again, you have to create connection object, connection.roll. So any of the transaction is going to be failed when you have to roll back to make certain revert or undo about all your changes into data. So these two methods are very important for transaction management and performing transaction into database. Now there are some specific steps to manage MySQL transaction in Python. These few steps have to follow. First is create MySQL database connections in Python, as we already done with that. Prepare the SQL queries that you want to run as a part of the transaction. For example, for bank transfer, we can combine two SQL queries, one for withdrawal money and other is for deposit money query. So two queries in a single transaction. We have to prepare those SQL. Next is set an auto commit property. By default, you all know it's a false. It may be true or false both to enable or disable. The property of MySQL connection to false. The next one is execute all queries one by one using cursor.execute. So cursor here is cursor object. And here we have to execute that using execute method. If all queries execute successfully, then commit the changes to the database. If one of the queries failed to execute rollback, any of, suppose 4 or 5 queries running in a single transaction, if any of these queries is going to fail, then roll back all the changes, revert all the changes, or undo all the changes to the database with respect to the transaction. Catch any SQL exception that may occur during the process, and close the cursor object and MySQL database connection. Once whole segment is complete, you have to just close the cursor object and MySQL database connection, which is very good practice. Now, all these steps, if we just try to understand these things through this diagram, we are going to initiate a transaction. Transaction is a small unit in which there are several low-level tasks. To combine those low-level tasks into a single unit, that is considered as transaction. So here we have query 1, query 2, and so on till query n. So if all the queries executed successfully, all means all, commit the transaction and transaction succeeded, make changes to the database. If any of the query failed, out of suppose n queries, if any of the query fails, roll back, undo, revert the changes, and transaction failed. So this is wonderful that scenario we have while managing the transactions and performing transactions into database, and this holds everywhere. You will have that PHP and you can say MySQL connections. You may have Java with MySQL, and you may have Python with MySQL. So any given database, any front end or back end, these asset properties are very, very important because of database and its management is very, very crucial. Now, this is that we have from here. I will share Jupyter Notebook with you and just given you an example of one of this segment. This is an example. Firstly, we import MySQL.connector, then create the connection object, pass these four parameters: hostname, username, password, database, create cursor object, and finally in the try, we call this method execute, delete from employee where department ID 201. So what this query does, this query will delete the record having that department ID 20 that we have already initially created in previous videos, all these tables and databases. So from employee table, all records are going to be deleted having department ID 201. Then you just commit the transaction and print delete. If something which is having some error, then it cannot delete and rollback method will be called. And finally, you close connection object and finally check the result. So when you run this, it will give you deleting. So as we have created previously, if you see that we have same sort of a table having 202, 201, 201 CSE, 201 CSE. So if we just look at our table that we have created previously, then we see that there is no that department ID of 201 in employee table. This is the employee table under this test database. So you are just seeing that there is no record with department ID 20. So this is the way that we may understand the concept of that performing transactions into database using different methods, and this is important topic for database management, and usually you see some of the queries, some of the questions in your university exams as well as in company interview. So it's important to understand practically and theoretically. Thank you so much. If you like these videos, please subscribe my channel and press the bell icon so that whenever I upload new video, you may get notification. Thank you very much. Have a nice day.